Good morning, everybody. Today we are going to talk about a new branch in mathematics, which is trigonometry. In this branch we are going to deal with triangles, and of course we know that any triangle has 6 elements, 3 sides and 3 angles. In this branch we are going to we are going to try to find the unknown measurements part of triangles, like angles or. So before we start, let's revise some important remarks, like, as we said, the sum of any two complementary angles equal 90 degree. What about the supplementary angles? Of course, it's equal sum of any two supplementary angles equals 180 degree. Sum of interior angles of triangle equal 180 degree. Let's take an example. If I said that the ratio between the measure of two supplementary angles is 5 to 11. How to find the degree measure of each of them? We are going to say that the ratio between the two angles 5 to 11. So I'm going to, instead of saying that 5, I'm going to say that the first angle equal 5x and the second will be 11x. And of course we say that two supplementary angles means their sum equal 180 degree. So I can say that 5x plus 11x equal 180 degree. Finally, I can say that 5 plus 11 equal 16x equal 180 degree. And I can find the value of x by dividing both terms by 16. So x will be equal 11.25. How to find the measure of the first angle and the measure of the second angle? The measure angle of the first angle equal 5x. That means 5 times 11.25. And second angle equal 11x. That means 11 times 11.25. So if you need if you want to be sure or make sure that your answer is right, the sum of the two angles should be equal or must be equal 180 degree. Let's take another example, which is if the ratio between the measure of the angles of the triangle equal 2 to 3 to 1. Here I have 3 angles of triangle and the ratio between them 2 to 3 to 1. And I need to find, of course, the measure of each angle in the triangle. First, you have to assume that the first angle will be, instead of 2, it will be 2x, and the second will be 3x. Finally, the third will be 1x. We know. What about the sum of angles of the triangle? We know that sum of interior angles of triangle equal 180 degree. So I have 2x plus 3x plus x equal 180 degree. What about 2 plus 3 plus 1? It will be 6x equal 180 degree. How to remove this 6? It will be x only. X equal 180 divided by 6. Finally, we know that x equals 30 degree. How to find the measure of the other angle? The first one, which is 2x, it will be 2 multiply 30, and the second one equal 3x, which will be 3 times 30. That means 90 degree. So I have here the three angles 60, 90, and finally we know that the third one equal 30. Another thing a very important thing that we have to revise, which is Pythagoras theorem. Pythagoras theorem, first we talk about the right angled triangle, and the side which is opposite to the right, the red one, is called the hypotenuse. And here we have two legs, which is the two sides of the right angle, AB and BC. Here I need to find the length. If I need to find the length of AC, which is the hypotenuse size, or the greatest one, sorry. So AC square will be equal AB square plus BC squared. What about the two legs? If I need to find the two legs, one of the two legs, AB or BC. If I need to find AB or BC, I'm going to subtract like this. If I said that AB square will be AC square minus BC square. Of course, squares means power 2. Of course, I say that I'm going to subtract, so I'm going to start with the greater one, which is AC. AC should be the first side because AC is the greatest side in the triangle. Finally, I can say that BC square equal AC square minus AB. Here I have, this is the first acute angle. At the vertex of any acute angle, I can make a V letter. This V letter contains two sides. One of them, of course, will be the hypotenuse side, and the other is called adjacent. So the adjacent side, this is the adjacent side, for this angle, and the other side will be the opposite. And if I'm going to talk about the other angle, I'm going to make a V letter like this, and of course one of them will be the hypotenuse and the other will be the adjacent. In this case, the third side will be the opposite side. Here I need to find the hypotenuse, adjacent, opposite for the marked angle. First here I need to find the hypotenuse in this triangle, the side which is opposite to the right angle, which is QR, like this. And what about the adjacent? Here I'm going to make a V letter like this, so it will be PQ, and finally the opposite side will be PR. Go to the second one. Here I need to find first the hypotenuse in this triangle, the side which is opposite to 90, YW, excellent. And I need to find the adjacent for 43, or the marked angle. The adjacent, I'm going to make a V letter, and the other side will be YX. Finally, I need to find the opposite side, which is XW. Finally, the last one, what is the side which is opposite to the right, which is AC, and I need to find, of course, the adjacent side. I'm going to make a V letter at this angle. Finally, I can say that the adjacent side will be BC, and the third one will be AB. In this lesson, we are going to talk about the trigonometric ratios of the acute angle. If we have a triangle, right angled triangle like this, and I have angle one of the two acute angles, of course I know that I have the side, first one is the hypotenuse and the adjacent side here, and the last one is the opposite. Type. How to find the first ratio? The first ratio is called, here I have sine. Sine will be opposite over hypotenuse, and the other one will be cosine adjacent over hypotenuse, and the last one will be tangent ratio, which is opposite. Finally, I can say that the main trigonometric ratios for any acute angle can be written as, first one is sine opposite over hypotenuse, and the other, or the second one, will be cosine adjacent over hypotenuse, and the last one, which is tan equal to opposite over adjacent. Let's see an example. Let's take an example. Here we have a right angled triangle, and I need to find the sine and the cosine and the tan, or the main trigonometric ratios of angle A. Here I have, for angle A, of course the hypotenuse will be AB, and the opposite side will be BC. Finally, I can say that AC is the adjacent angle. How to find? I'm going to start with tan theta, tan equal opposite over adjacent, which is 8 over 15. Which of the following statements is true for the triangle? I have for angle x, 8 centimeter would be excellent. The adjacent side, 8.5 centimeter would be the hypotenuse side. Finally, 3 centimeter would be the opposite side. Which of the following are statements is true? Of course, tan will be 3/8, which is opposite over adjacent. Which of the following statements is true also? I have here for angle x, the hypotenuse equal 8.9 and the adjacent equal 8 centimeter. Finally, 4 centimeter for the opposite side. Which of the following is right? Of course, cosine theta would be 8/8.9. Here we have which of the following statement is true for the triangle. I have here sine, tan, and also sine. It will be 4.8/12, opposite over hypotenuse. Excellent. Another one, for this angle I need to find which statement is true, tan or cosine or sine. Of course, the first one, which is opposite over adjacent, 4/tan, which is equal 0.4. Another one. Finally, I need the true statements. Sine theta equal 0.8. That means sine theta equal opposite over hypotenuse 4/5, which is equal 4.8. Another one, I have here a triangle, and I have two acute angles in this triangle, and I need to find which of them is wrong. Which of the following statements is wrong? I have here the first one, cosine 22.6 to 12/13, and then excellent. The last one, the second one, tan 67.4 equal 5/12. This is the